Welcome to another lesson of Math 1314 College Algebra. Today we will be discussing Section 2.6, Other Types of Equations. In this section we will solve equations with rational exponents, solve equations using factoring, solve radical equations, we will solve absolute value equations, and we will solve other types of equations. We'll start with solving equations with rational exponents. Rational exponents. A rational exponent indicates a power in the numerator and a root in the denominator. This can be expressed in a number of ways. You can have a, the base, raised to the m over n power. You can have a to the 1 over n, the whole thing raised to the m power. You can have a to the m raised to the 1 over n power. And you can have the nth root of a to the m or the nth root of a all raised to the m power. Now, each one of these has a utility, and you can use it when you have a problem that, say, is easier to square first than it is to take a cube root. Or is easier to take a cube root first than it is to raise to the 5th power. So you choose the format that works best for the problem that you're working on. Let's do an example using a real number raised to a rational exponent. In this example, we want to evaluate 27 to the 2/3 power. I'll rewrite that 3. So how do we want to rewrite this? Well, I think it will be a lot easier if we take the cube root of 27 first. So the way I want to rewrite that as 27 to the 2/3 is equal to the cube root of 27 quantity squared. Well, the cube root of 27 is 3 squared, which is 9. So again, I chose one of the formats that made sense to simplify and evaluate this number. Now let's try it using variables. So we now want to solve an equation and solve this one in which a variable is raised to an exponent. So we have x to the 3/2 power is equal to 125. So how do we remove the exponent on x? Well, we raise both sides of the equation to the power that's the reciprocal of the power we have. So let's rewrite this. X to the 3/2 is equal to 125. So we want to raise it to the reciprocal power. The power we have is 3/2, so we want to raise it to the 2/3 power on both sides. So we'll have x is equal to 125 to the 2/3 power. Well, how can we rewrite that in a way that makes sense? Well, we can take the cube root of 125 and then raise that to the 2nd power. Well, the cube root of 125 is 5, and we can square that. And so we're left with 25. So x is equal to 25. X is the solution to this equation. 25 raised to the 3rd power, and then take the square root, you get 125. You can check that to verify, but that would be your answer in this example. Let's try an equation that involves rational exponents and factoring. In this case, we want to solve 3x to the 3/4 power is equal to x to the 1/2 power. The first thing we want to do to be able to solve this is we want to have a 0 on one side. We want to be able to use the zero product property. So we'll rewrite this as 3x to 3 to the 4th equal to x to the 1/2 power. And we'll subtract x to the 1/2 power from both sides. So we're left with 3x to the 3/4 power minus x to the 1/2 power is equal to 0. Now, can we factor on the left-hand side? Well, we have x's in both cases, but what can we factor out? Well, we always factor out the term with the lowest exponent. Which exponent is the lowest? Well, 1/2 is smaller than 3/4, so we need to factor out the 1/2. Let's make sure we have a common denominator just to make this a little easier. 3x to the 3/4 minus x to the 2/4 is equal to 0. So what we can do now is we can factor out that x to the 2/4. And what are we left with? Well, we're left with 3x to the 1/4. That's the property that says that when we multiply exponents, we add them. Minus, well, this is the same term that we have on the outside, so it's minus 1 is equal to 0. So if we were to distribute, we would get x to the 2/4 times 3x to the 1/4. That gives us 3x to the 3/4, and then we distribute again. X to the 2/4 times negative 1 is minus x to the 2/4. Okay, so now we know using the zero product property that either this part is 0 or this part is 0. So what we can do is say x to the 2/4 is 0 or 3x to the 1/4 minus 1 is 0. And now we have two equations that we can work through to solve. Well, in the first case, the only way x to the 2/4 power is equal to 0 is if x is 0. The only way we get a 0 power out is if x is 0. Okay, so now on this side, 3x minus 1 is 0. We can add 1 to both sides. So we're left with 3x to the 1/4 power is equal to 0. No, not 0, 1. We just added 1. We can divide both sides by 3. And we get x to the 1/4 power is equal to 1/3. Okay. Now, how do we get rid of the 1/4 power on x? Well, we raise both sides to the reciprocal power, which is 4 over 1. So x is equal to 1/3 raised to the 4th power. So using exponent properties, that's equal to x is equal to 1 to the 4th power, which is just 1, over 3 to the 4th power. Make sure I make that clear that that's an exponent. And 3 to the 4th power is 81, so we're left with x is equal to 1 over 81. So our two answers are x equals 0 or x is equal to 1 over 81. So you'll probably want to practice this, but remember, when you're factoring out a rational exponent, you need to factor out the lowest exponent. Let's do a different example. For our next examples, we will need to have the definition of a polynomial equation. A polynomial of degree n is an expression of the type a subscript n times x to the n power plus a subscript to the n minus 1 times x to the n minus 1 power plus all the terms in the middle plus a2 x squared plus a1x plus a0, where n is a positive integer and the a subscript n to 0 are real numbers, and the leading coefficient a subscript n is not equal to 0. If we set this polynomial equal to 0, it gives us a polynomial equation. The total number of solutions, both real and complex, to any polynomial equation is equal to the highest exponent, n. So let's do an example of a polynomial equation and solve for x. Let's solve by factoring 12x to the fourth equals 3x squared. What can we do first? Well, we subtract 3x squared from both sides to get 12x to the fourth minus 3x squared is equal to 0. So we have a polynomial equation. We should expect at most 4 solutions because x is raised to the fourth power. What can we factor out? Well, we want to try and factor out the lowest power on x, or x squared. But we can also factor out a coefficient because we have 12 and 3, or negative 3. And we can factor out a 3. So let's factor out 3x squared. And that leaves us with 4 times x squared minus 1. 4 times x squared minus 1 is equal to 0. Now, can we factor this any further? Can we do anything with the 3x squared? Well, we can't do anything with the 3x squared. Can we do anything with the 4x squared minus 1? Does that look familiar to you? Is that one of the special cases that we've seen before? Well, to me, it looks like that's a difference of squares. Let's rewrite it. 3x squared times 2x quantity squared minus 1 squared. So that's a difference of squares. What we can do is we can rewrite that as 2x, the first thing squared, plus 1, the second thing, times 2x, the first quantity that's squared, minus the second quantity that's squared, is equal to 0. So now what we have is something that we can look at and find at least 3 real solutions. So let's set each of those equal to 0 and use the zero product property. So 3x squared is equal to 0, or 2x plus 1 is equal to 0, or 2x minus 1 is equal to 0. Well, in the first case, the only way 3x squared can be 0 is if x is 0. In the second equation, we can subtract 1 from both sides. So 2x is equal to negative 1. Divide both sides by 2. So x is equal to negative 1/2. And then the third equation, go ahead and box those in so we know those are our solutions. We can add 1 to both sides and get 2x is equal to 1. Divide both sides by 2. And you get x is equal to 1/2. So, with our factoring, we first factored out a greatest common factor, and then we found that we had a difference of squares, and so we were able to get 3 solutions just by factoring. And it turns out that we actually have a double solution with x equals 0. Okay, let's do a different type of factoring. Let's now solve this polynomial by grouping. So we're factoring, and we're going to try and group and then factor again. So we have x cubed plus x squared minus 9x minus 9 is equal to 0. Well, it looks like we can deal with 2 separate groups. We have a greatest common factor in this group, and then we have a greatest common factor in this group. So maybe we can factor and get something that will be helpful for us. So in the first 2 terms, what can we factor out? Well, we can factor out the lowest power term. So we can factor out an x squared. So we're left with x plus 1. Okay. And then we can factor out a negative 9 in the second set, minus 9. And 9 times x gives us negative 9x. And negative 9 times 1 gives us a negative 9. So now we can factor out an x plus 1 factor, since we have that common to both terms. And what's left is x squared minus 9 is equal to 0. Well, there we have something again that is a difference of squares. Let's rewrite it as x plus 1 times x squared minus 3 squared is equal to 0. Again, 3 squared is 9. So we can rewrite that as x plus 1, x plus 3, x minus 3 equal to 0. So again, we have 3 different values. So x plus 1 is equal to 0, or x plus 3 is equal to 0, or x minus 3 is equal to 0. So the first one, we subtract 1 from both sides. X is equal to negative 1. We subtract 3 from both sides in the second equation, so x is equal to negative 3. And then we add 3 to both sides on the last equation to get x is equal to positive 3. So those are our 3 solutions after factoring by grouping and then factoring that difference of squares. Let's now solve radical equations. First, we need a definition and some steps on how to solve radical equations. An equation containing terms with variables in the radicand, that's the stuff under the radical symbol, is called a radical equation. Now, how do we solve a radical equation? Well, if we're given a radical equation, we can solve it. If we're given a radical equation, the first thing to solving is to isolate the radical expression on one side of the equal sign. Put all terms, let's say all other. If we're given a radical equation, the first step in solving it is to isolate the radical expression, that's the things that have a radical sign, the radical symbol, on one side of the equal sign. We want to put it all on one side. And then we want to put all of the other terms on the other side of the equal sign. The second step is to raise both sides of the equation to the power of the root. So if you have a square root, then you square both sides of the equation. If you have a cube root, then you raise both sides to the third power. So whatever the power of that root is, you raise both sides to that power to eliminate the radical symbol. The third step is to solve the remaining equation. See if I can get a better circle here. Solve the remaining equation. Fourth, if a radical term still exists, then repeat steps 1 and 2. And then finally, you want to check and confirm solutions by substituting them into the original equation. Let's try an example. Let's solve the following radical equation. We have the square root of x plus 3 equal to 3x minus 1. We first need to square both sides of the equation, which leaves us with x plus 3 is equal to 3x minus 1 quantity squared. So we need to do binomial expansion on the right side. So that's 3x minus 1 times 3x minus 1. So on the left-hand side, we have x plus 3 is equal to 3x times 3x is 9x squared. 3x times negative 1 is negative 3x. Negative 1 times 3x is minus 3x. And negative 1 times negative 1 is plus 1. So what we have is x plus 3 is equal to 9x squared minus 6x plus 1. We can subtract 3 from both sides to get x is equal to 9x squared minus 6x minus 2. And then we can subtract x from both sides to get 0 is equal to 9x squared minus 7x minus 2. So now we can take 9x squared minus 7x minus 2 and factor that. So let's do that. So I'm going to rewrite this as 9x squared minus 7x minus 2 is equal to 0. So we need the factors of negative 18, that's a times c, that add to negative 7. What are the factors of negative 18? Well, we have 2 and negative 9, negative 2 and 9, 3 and negative 6, negative 3 and 6. So now we consider the sums. 2 and negative 9 sum to negative 7. Negative 2 and 9 sum to 7. 3 and negative 6 sum to negative 3. And negative 3 and 6 sum to 3. So which pair gives us negative 7? Well, it's 2 and negative 9. So we can rewrite the equation as 9x squared minus 9x plus 2x minus 2 is equal to 0. Now we can factor by grouping. We can factor out a 9x from the first two terms. That leaves us with x minus 1. And then from the second two terms, we can factor out a 2. And we're left with x minus 1. Now we have a common factor of x minus 1, so we can factor that out and have 9x plus 2 left. So we can solve both of these and say x minus 1 is equal to 0 or 9x plus 2 is equal to 0. Okay, well, x minus 1 equal 0, we can add 1 to both sides and have x is equal to 1 is the solution. Do a better box there. And then we can solve for x here, minus 2 from both sides. And we have 9x is equal to negative 2. And then we can divide both sides by 9. And that leaves us with x is equal to negative 2/9. Then we can divide both sides by 9. and get x is equal to negative 2/9. But let's remember back to the very beginning. Let's scroll up. To get from the square root, to get rid of that radicand, we had to square. So that means that only the positive value is a solution. So that means that this x equal to negative 2/9 cannot be a solution to this radical equation. Only the x equals 1. So when we squared both sides of the equation, we removed the possibility of having a negative solution. What happens if we have an equation that has two radicals? Well, let's first try and solve this example. The square root of 3x plus 7 plus the square root of x plus 2 is equal to 1. So the thing that we want to do first is to isolate one radical on one side. So we'll first subtract the square root of x plus 2 from both sides. And so we're left with the square root of 3x plus 7 is equal to 1 minus the square root of x plus 2. So now we can square both sides. And we're left with 3x plus 7 is equal to, and this time I'm going to actually write out the square root portion as two factors. So I will need to double distribute. So I have 1 times 1, which is just 1. And then I have 1 times a negative square root of x plus 2, which is negative square root of x plus 2. Then I have negative x plus 2 times 1, which is another minus square root of x plus 2. And then I have plus square root of x plus 2 quantity squared. So in a rewrite, we have 3x plus 7, and we have that's equal to 1 minus 2 times the square root of x plus 2 plus, and I have the square root of x plus 2 quantity squared, and so that eliminates the radical there, so plus x plus 2. Now we have one more radical that we need to get rid of. So what we can do is we can isolate that radical expression. So let's do one more rewrite. That's 3x plus 7 is equal to 1 plus 2 is 3. So we have 3 plus x plus the square root of x plus 2. We can subtract 3 from both sides to get 3x plus 4 is equal to x plus the square root of x plus 2. And then we can subtract x from both sides to get 2x plus 4 is equal to the square root of x plus 2. Now we're finally in a place where we have the square roots things, the things under the radical, isolated. So now we can square both sides, and we're left with 2x plus 4 quantity squared is equal to x plus 2. Okay, so now we'll again do a binomial expansion. 2x plus 4 times 2x plus 4 is equal to x plus 2. 2x times 2x gives us 4x squared. 2x times 4 gives us plus 8x. 4 times 2x gives us plus 8x. And 4 times 4 gives us plus 16. So 4x squared is equal to x plus 2. So 4x squared, we have two terms that are 8x plus 16x. Plus 16 is equal to x plus 2. We can now subtract x from both sides and get 4x squared plus 15x plus 16 is equal to 2. And then we can subtract 2 from both sides to get 4x squared plus 15x plus 14 is equal to 0. Now, are we done here? Or will this factor? Or are there other ways to solve it? Let's take a look. Let's try to factor our resulting equation. So we first need to multiply our leading coefficient, which is 4, times our constant, which is 14. 4 times 14 is 56. We want to know the factors of 56 that when they're added, we get 15. So let's do some factors of 56. Well, there's 1 and 56. There's 2. 2 and what? What is our other factor there? 28. 3 is not a factor. And 4 and 14. What other factors do we have? 7 and 8. So let's do the sums. 1 and 56 adds to 57. 2 and 28 is 30. 4 and 14 is 18. And 7 and 8 is 15. And we wanted 15. So what we can do is we can ungroup the 15x and get 4x squared plus 8x plus 7x plus 14 is equal to 0. And then we can factor by grouping these two different groups. We can factor out a 4x from the left group, and we get x plus 2. And then we can factor a 7 out of the second group to get x plus 2 is equal to 0. And then finally, we can factor out an x plus 2 as a common factor, and we're left with 4x plus 7 is equal to 0. Now we can set each of these factors to 0. X plus 2 is equal to 0, or 4x plus 7 is equal to 0. Well, if we subtract 2 from both sides, x equals negative 2. We'll talk about that in a second. And then we can subtract 7 from both sides, and we're left with 4x is equal to negative 7. Then we can divide both sides by 4, and we're left with x is equal to negative 7 over 4. So we have x is equal to negative 2, or x is equal to negative 7/4. Now, does this give us a solution? Okay, now that we have these two proposed solutions, let's plug it back into the original equation and see if these are actual solution or extraneous solutions. So let's try x is equal to negative 2 first. So we have the square root of 3 times negative 2. We're plugging in x, which is negative 2, plus 7, plus the square root of negative 2 plus 2. And we want this to be equal to 1. So 3 times negative 2 is negative 6 plus 7, plus the square root of negative 2 plus 2, which is 0. So we have the square root of negative 6 plus 7 is the square root of 1, plus the square root of 0, which is just 0. And the square root of 1 is just 1. So x equal to negative 2 is a solution. Let's plug in x is equal to negative 7 over 4. So again, we have the square root of 3 times negative 7 over 4 plus 7 plus the square root of negative 7 over 4 plus 2. Well, that gives us the square root of negative 21 over 4 plus 7 plus the square root of negative 7 over 4 plus 2. We can get a common denominator here of 4 in the first radical. That gives us negative 21 over 4 times, let's see, What value do we need to get a denominator of 4? Well, that would be 4 over 4, so 28 over 4, plus the square root negative 7 over 4, plus 8 over 4. Okay, so that gives us the square root of negative 21 plus 28, which is positive 7 over 4, plus the square root of 1 over 4. So after doing those evaluations, the square root of 7 over 4 plus the square root of 1 over 4 is not equal to 1. So x equals negative 7 over 4 is an extraneous solution. And this is why we check our solutions. So now that we've discussed radical equations and how to solve them, that last example was quite a task, took a lot of steps. Let's discuss a little bit about solving an absolute value equation. There are a number of things to consider with dealing with absolute values. The first is the definition of what the absolute value is. The absolute value of x is written as, with straight bars, absolute value with x in the middle. It has the following properties. If our value x is greater than or equal to 0, then the absolute value of x is just x. If x is less than 0, then the absolute value of x is negative x. It's the distance from 0 to x, and it's always positive, or 0. For real numbers a and b, an equation, absolute value of a equal to b, where b is greater than or equal to 0, will have solutions when a is equal to b or a is equal to negative b. If b is less than 0, the equation absolute value of a equal to b will have no solution. The absolute value equation can never be negative. Let's consider some more properties. An absolute value equation of the form absolute value of ax plus b equal to c has the following properties. If c is a real number and c is less than 0, then the absolute value of ax plus b equal to c has no solution, as we said before. If c is equal to 0, the absolute value of ax plus b equal to c has exactly one solution. And then if c is greater than 0, then the absolute value of ax plus b equal to c has two solutions. So, if we're given an absolute value equation, how do we solve it? Well, if we're given that equation, the first thing we want to do is to isolate the absolute value on one side of the equal sign. If the c is greater than 0, then we can write and solve two equations, which is ax plus b equal to c and ax plus b equal to negative c. Now that we have the definition of absolute value and what absolute value equations look like with ax plus b inside of them, let's find the solution to some absolute value equations in the next example. Let's solve the absolute value equation. Absolute value of 1 minus 4x plus 8 is equal to 13. Now, the first step that we take in solving an absolute value equation is to isolate the absolute value expression on one side of the equal sign. The way we do that in this case is to subtract 8 from both sides, and we're left with absolute value of 1 minus 4x is equal to 13 minus 8, which is 5. So what this tells us is that c is equal to 5. 5 is greater than 0, so that means we have two solutions. And the way we write that out is the absolute value of 1 minus 4. Oh, we don't need the absolute value anymore. We can rewrite this as 1 minus 4x is equal to 5, or 1 minus 4x is equal to negative 5. Once we solve both of those equations, then we have the two solutions. So we can add 4x to both sides on this one. We have 1 is equal to 4x plus 5. We can subtract 5 from both sides, and we're left with negative 4 is equal to 4x. Divide both sides by 4, and we get x is equal to negative 1. That's our first solution. Our second, we can add 4x to both sides. We're left with 1 is equal to 4x minus 5. We can add 5 to both sides. And we're left with 6 is equal to 4x. Divide both sides by 4. And we're left with 6 over 4 is equal to x. And that's our other solution. So the solutions to the equation absolute value of 1 minus 4x equal to 5 are, rewrite that, are negative 1 and 6 over 4, or 3 over 2. X equals negative 1 and x equal 3 over 2 in the fully reduced form. And that will work similarly for other examples and problems you may see. If you have any issues with that, be sure to email me and I can help you work through more examples. Solving equations in quadratic form. If the exponent on the middle term of a trinomial is 1/2 of the exponent of the leading term, then we have an equation in quadratic form, which we can solve like a quadratic with a clever substitution. So if we do have an equation in quadratic form, how do we solve it? Well, there are some steps that we can follow to solve this equation. We first identify the exponent on the leading term, that's the term with the highest power exponent, and determine if it is double the exponent on the middle term. If it is the case that the leading term exponent is double the exponent on the middle term, we can substitute a variable for the variable portion of the middle term. That should say portion there. Let's rewrite that so you can see it. Then you need to rewrite the equation, the substituted equation, in standard form. Then you solve the quadratic using one of the three methods that we've discussed, whether by factoring, by completing the square, or by using the quadratic formula. Then you substitute back into the original equation and solve the remaining equation given what you have from solving the quadratic. That can give you the solutions to higher power equations using the same tools that we've learned with quadratics. Let's try an example and see if we can put this into action. So in this example, we want to solve using substitution the equation x to the fourth minus 8x squared minus 9. So is the exponent on the leading term, which is 4, double the exponent on the middle term, which is 2? The answer is yes. So what we want to do is we want to substitute a variable. Let's use u in for x squared, the variable portion of the middle term. So let u equal x squared. So what that means is we can substitute in u everywhere we see an x squared. So we have u squared, which is x to the fourth, minus 8u minus 9 is equal to 0. Can we solve this? Let's try to factor it first. We have a leading coefficient of 1, so we just need to look for the factors of negative 9 that add to negative 8. So we have 1 and negative 9, negative 1 and 9, 3 and negative 3, and that's the only ones. So the sums give us 1 plus negative 9 gives us negative 8, negative 1 plus 9 is 8, and 3 minus 3 is 0. So the factors we want to choose are 1 and negative 9. So what this gives us is u plus 1, u minus 9 is equal to 0. So either u plus 1 is equal to 0 or u minus 9 is equal to 0. So we can subtract 1 from both sides. U is equal to negative 1. Or, adding 9 to both sides, u is equal to 9. Now, what did we have in the first place? Well, we can back substitute. Everywhere we see a u, we can put an x squared. So x squared is equal to negative 1, or x squared is equal to 9. Can we take the square root of both sides? Well, let's start with the one on the right. X squared equal to 9. Taking the square root of both sides there, we get plus, or x is equal to plus or minus the square root of 9, or x is equal to plus or minus 3. What about x squared equal to negative 1? Well, we can clear the square by taking the square root of both sides. Again, we have to have the plus or minus. So x is equal to plus or minus the square root of negative 1. What do we know about the square root of negative 1? Well, the square root of negative 1 is I. So x is equal to I. X is equal to negative I. X is equal to 3. And x is equal to negative 3 are the four solutions of this fourth degree polynomial. And we found that by using substitution of u in for x squared. Let's do another example. This case, we want to solve x minus 5 quantity squared minus 4 times x minus 5 minus 21 equal to 0. Is the power on the leading coefficient double the power on the middle term? Well, in this case, we have a 2 and a 1, so that is the case. So we want to let u equal x minus 5. So everywhere we see an x minus 5, we'll substitute a u. So we have u squared minus 4u minus 21 is equal to 0. So we want to know what the factors of negative 21 are. That give us negative 4. So you have negative 3 and 7. 3 and negative 7. 1 and negative 21. Negative 1 and 21. So the sums, negative 3 and 7 give us positive 4. 3 and negative 7 give us negative 4. 1 and negative 21 is negative 20. And negative 1 and 21 is 20. So the one that gives us negative 4 is 3 and negative 7. So we can rewrite this as u plus 3, u minus 7 is equal to 0. 3 is equal to 0, or u minus 7, not equals, u minus 7 is equal to 0. Subtract 3 from both sides. You have u is equal to negative 3, or adding 7 to both sides, u is equal to 7. Now we can substitute back in, and we get x minus 5 is equal to negative 3, or x minus 5 is equal to 7. We can add 5 to both sides on the first equation. We get x is equal to 2, or we can add 5 to both sides of this equation, and we get x is equal to 12. So our solutions to this equation are x equals 2 and x equals 12. And you can go back and plug that in and check to verify that those are in fact solutions at your own leisure. Let's do one more example, which is solving a rational equation that leads to a quadratic. In this example, we want to solve 3x plus 2 over x minus 2 plus 1 over x is equal to negative 2 over x squared minus 2x. Now we want to be able to clear these denominators. The first thing that I want to do is to see if we can factor any denominators. Well, we can on the right-hand side, so let's rewrite 3x plus 2 over x minus 2 plus 1 over x is equal to negative 2 over, we can factor out an x, so we get x minus 2. So what this tells us is that our least common denominator is what? Well, the least common denominator is x times x minus 2. So we'll multiply both sides of the equation by x times x minus 2. Just copy this down. So on the left-hand side, we're left with x times 3x plus 2, that denominator x minus 2 cancels, plus x times x minus 2 over x leaves us with 1 times x minus 2 is equal to, and in this case, the denominator and the numerator here are the same, so we're left with just negative 2 because these will cancel. So now we can expand. X times 3x is 3x squared. X times 2 is plus 2x. Plus x minus 2 is equal to negative 2. So we can combine like terms to get 3x squared plus 2x plus x is 3x. Minus 2 is equal to negative 2. Then we can add 2 to both sides. Oops. Plus 2 to both sides. Scroll up just a bit. We get 3x squared plus 3x is equal to 0. Now we can simplify this further by factoring out a 3x. That leaves us with an x plus 1 equals 0. So either 3x is equal to 0 or x plus 1 is equal to 0. So we can divide both sides by 3 on the first equation. X is equal to 0. Or we can subtract 1 from both sides. We're left with x is equal to negative 1. Now we need to go back and plug both of those solutions into our original equation to see, 1, that it works, and 2, that we don't have any problems with division by 0. So in our original equation, let's copy that equation down. 3x plus 2 over x minus 2 plus 1 over x is equal to negative 2 over x squared minus 2x. Well, I can already see that if we put x equals 0 into this portion right here, we will get division by 0. So that cannot happen. So what happens when we plug in -1? Well, if we plug in -1 to this denominator, that gives us -1 minus 2. That's 3. That's fine. What if we plug it into the x squared minus 2x part? Let's try that. So -1 squared minus 2 times -1. Well, -1 squared is just 1 minus 2 times -1 is plus 2. So that gives us 3. So that's perfectly fine. We don't get division by 0 there. So let's plug in, for all of the x's, this -1 and see if that works. So 3 times -1 plus 2 over -1 minus 2 plus 1 over -1. So that gives us 3 times -1 is -3 plus 2 is -1 over -1 minus 2 is a -3 plus a -1, so minus 1. What does that give us? Well, that gives us -1 over -3, which is 1 over 3 minus 1. Or, what's 1/3 minus 1? Is that -2/3? -2/3. Okay, so let's plug in the -1 in the right side of our equation. That gives us -2 over -1 squared minus 2 times -1, which is -2 over -1 squared is 1, and then -2 times -1 is positive 2. So we're left with -2 over 3. So x equals -1 is a solution to the equation. So just be very careful that you don't let a solution divide part of a rational equation by 0. That will cause a problem and make a solution invalid. Be on the lookout for quadratics where you can substitute with half powers on a middle term from the leading coefficient. And that will conclude section 2.6. If you have any questions, be sure to email me and I will get back with you. Good luck on the homework.